Okay, hello everyone. My name is Livnat Peer. I'm a senior engineering manager at Red Hat. And if you are here, you're probably very interested in networking because the competition is lunch. So it's like, I have no way to win. What we're going to talk about today is stretching the open source network. The first half of the session, and I'm hopefully going to make it very quick, is about what challenges do we see in the cloud era for the networking? What are the requirements from the network? Because that's obviously changing, and we are gaining more and more requirements as we go. And then the second half of the session would be about what open source tools you can use to handle and to deal with the challenges that we see. So let's get started. First, I'd like to go over some of the workloads and platforms that we need to deal with, because one of the main challenges we actually need to deal with is when we talk to customers or when we talk to people who are interested in setting their infrastructure, they actually don't know what they need. They know a lot of buzzwords, they know what they should say, but do they really know what we need? So let's see what type of workloads we need to deal with these days. So I'm taking you almost a decade back. It's not like to the cosmic dust that Rona was talking about in the keynotes. It's just like 10, 15 years ago. Most small, medium companies, as well as large companies, as well as telcos and service provider, everyone had on-premise hardware. They needed to run their workloads, they used their hardware, whatever they have, that's what they get. And till this day, we can see some workload that is running on bare metal. For legacy reasons, obviously, but also because some workloads actually leverage specific hardware, cards, devices, and they need the bare metal machine. So it's a really small amount of workloads, but it's still there. And when we're talking about what potential things we need to deal with, then still workloads that are running on bare metal is one of them. The most trending, and obviously like 80% of the workloads these days are being virtualized. They are running on virtual machine, not on container just yet. So mostly virtual machines. This is most of the things that we can see both on-premise and obviously in the public cloud. And there's a movement toward clouds. We're on Cloud Native Day. You can see many applications being either re-architecture for cloud native approach with serviceless and microservices and all the things we've been hearing about today. But you can also see some application being just deployed on containers without the re-architecture process that is required. But in both cases, what we need to deal with from the infrastructure perspective, we need to deal with a bare metal workloads, a virtual machine workloads, and a cloud and a container workloads. Okay, all of this is on premise. Let's move on. We also call it private cloud. It doesn't have to be a private cloud, but this is like the common way we treat these type of workloads these days. Extending that, we're moving into the public cloud. Public cloud is what everybody knows, Amazon, Azure, the Google cloud. There are other different public cloud these days. The companies, and we've heard the VP cloud from Outbrain earlier, she was talking about the need to burst and to scale out, and whatever you have to pay to maintain an on-premise data center is not going to cut it, because you need to probably extend, like there's more and more workload, and you can't scale out from day zero to what you would need 2 years from today. So you need some workload running on a public cloud. Also in the public cloud, you probably want some virtualized workloads, some containerized workloads, and still some bare metal. It's super expensive, but you can still get that also in public cloud. Next, and that's what we've been seeing, like we did the research on this for the past 3 years, but we can see it more and more coming up these days, which is the edge. When I'm pointing, like there's only one cube here, but when we're talking about the edge, we're talking about multiple, and actually a huge number of endpoints close to the customers, close to the end users, and we need to stretch our network to get to that, to there, like to be able to run workloads close to the user. That's the edge. So when we're looking about the network, or just from here, what you can see is that you need to run workloads on the edge, on-premise, and on public cloud. But all of this is just a collection of clouds until we move to what makes it a hybrid cloud, which is the future. Once we add into this drawing a shared networking experience, when you can move workloads seamlessly from your on-premise site to the public cloud or to the edge, which is usually also hardware you can either loan or own, depends. Once you get to a shared networking experience, that's where you actually get into hybrid cloud. And this is the vision. This is what we believe in. This is what we are working towards. So I'm going to read it to you because I think it's important. Open hybrid cloud is the vision of the IT architecture of tomorrow, where applications coexist and can move seamlessly across a hybrid environment of cloud footprints. And here comes the key point. So we include private cloud, we include multiple public clouds, and the edge. And multiple is the key word for open. What we've described earlier is what is a hybrid cloud. When you want to talk about open hybrid cloud, a key point for that is to adopt multiple public cloud. And why is that? When we have engineers writing applications and they are running the applications on public cloud, they are trying to leverage and starting to leverage more and more services available in the public cloud. That makes perfect sense. It's faster, it's easier, it's just there, right? Like if we need to deliver a software tomorrow, that's the way to do it, like leverage services existing. The problem with that approach is that you are being locked in once you do that. You cannot move your workloads to a different cloud once you're using, for example, Amazon or EC2 DynamoDB, okay? You're using their database, try to move that workload to Azure. Good luck with that, right? Like you would need to rewrite your entire persistency layer, or if you use another service like the messaging queues. Once you use a service, you have to be aware that you've made a decision to stay with that cloud. So if you want a open hybrid cloud for your company, a key point would be to leverage multiple clouds, to be able to migrate from one to another. That's a key thing. Okay, so our vision is like we want to move application everywhere and anywhere, and how do we do that? How do we get them from private cloud to public cloud to the edge and back? And we need to scale out and scale down, etc. So let's see what challenges we need to deal with towards a fully automated hybrid cloud networking stack. The first challenge is something we're all very familiar with. We solve it like hundreds times. You can find at least 10 good open source solutions that can deal with that. And that's the integrated network virtualization. We're talking about a single cloud, on-premise, single site. Usually what it is all about is about networking isolation. So you provide to your tenants network as a service. They can create a network. It's usually based on technologies like VLAN or tunneling, which is VXLAN, GRE, etc. So this is all, I hope, technologies we're well familiar with. Adding on top of that, the first bits of security, like if you use OpenStack, it's security group. If you use Kubernetes, that's the networking policy. Being able to control and manage what type of traffic goes into which type of workloads, that's a key part. Again, all of this is already solved. That's the first challenge. Then we have 2, 3, and 4, and they are all on the same slide, not because they are the same use case, they are completely different use cases, but from the technical point of view, the solution is very similar. So let's see what we're talking about here. We're talking about multiple sites, having like a typical use case when you have a company with multiple branches, getting the branches able to talk to each other, like connectivity, basic connectivity between branches, that's multiple sites. Multiple clouds is when you want to have in-house on-premise workloads and have the connectivity up to the public cloud. And the edge is when you want what comes from telco and Internet of Things, is that you want the core network to have connectivity to the edge, like the local endpoints. All of this seems to be different use cases, but the technology is the same. It's all about tunnel management these days. Actually, a combination of tunnel management and security. So if we're talking about technologies like IPsec or any type of VPN with combination of any type of encryption can solve you that requirement. And we're going to look at which open source tools can give you that. But basically, this is the next level of requirements that we have from our networking infrastructure. Another two set of challenges, and I hope that we will actually end with them. So the first is policy and management. Policy is the ability to define the policy in a single place and have it propagated into the different location of your cloud. So you would want to define your policy once, saying, for example, all of my database workloads, all of my application workloads can have connectivity to my database servers. That's an example. You want to define it once. You want this policy to propagate across your clouds. So all the workloads in the private cloud usually you would have some mechanism to propagate it. We'll see it later, the mechanism. And policy is one aspect. Monitoring is the other aspect, and that's probably not going towards what Rona was discussing this morning. So she was mentioning endorsing chaos. When you talk to IT people, it's never about endorsement and never about chaos. It's also about monitoring. I want to understand where my packets are getting lost. I don't want chaos. If something is disappeared, then I want to know at least at which part of the network I need to start looking into. I'm sure that if you're here, you spend a few or maybe a lot of hours just looking for the packets, right? It's amazing how they disappear and you have no tools to understand where they are. So part of the transition to the cloud era and all the networking layers that we have, because we are accumulating, right? Like it used to be the physical fabric, now we have the physical fabric and the infrastructure, and now we're moving from physical to infrastructure plus Kubernetes or whatever container management you choose. So it's like 3-4 layers, and then you have all the switches. So it's a lot of fun. Management is a key tool in order to solve that and to handle that. And the last bit is about fully automation. So we're growing. The workload is growing, and we need to be able to replicate deployments. Each deployment we're making, we want to be able to replicate it hopefully in a homogeneous way on another setup. So automation is a key tool for success in cloud area. You should be able to use tools that enable you to not do a manual labor work that is error prone. And I don't need to talk about automation because I'm sure you all understand how much it is important to us. If you have a solution of networking that answers all of the 6 challenges that I've listed here, then you have a winner, okay? I didn't see many, or I can say, to be honest, at all, a single networking solution that solves you all of these issues. They are not there, at least not from I'm aware of. So we're going to discuss a combination of open source tools that can answer hopefully all the 6 points that I've mentioned. But before we're going to go into that, I want to talk about a phased approach, and that is taking me a little bit back towards what do our customers need. Do they need a full solution that does everything? The answer 90% of the time is no. They don't need that. Let's not deploy something that is complicated, that is hard to maintain, how to solve, how to debug, how to monitor. Let's not take our customers to that spot. Let's see what other options do we have on the way to a full hybrid cloud, and let's maybe understand together what might be a better solution versus the full-blown deployment in our networking stack. So if you're a small company, maybe just a single cluster, single site thing can work for you. It's out of the box, it's easy. You probably don't even need to pay anyone to maintain it because it's so stable. It's been out there for a really long time. So just use it. Don't go to multi-cluster or multi-site. But if you're a bigger company, then probably multiple clusters is what you need. When we're talking about multiple clusters, first we're talking about multiple single clusters. They are not aware of each other. They do not. You do not expect to migrate workload between one to another, and you don't expect that you would mix and match workloads between the clouds. So multi-cluster is like the next level. You're big, but it's not interesting enough to get a complex networking stack. The next, that's a little bit more interesting. It's also already available today. It's a single control plane. We're calling it the stretch cluster, stretch site. So it's a single control plane stretching across multiple infrastructures. So, for example, you have your core network. You have the control plane deploy on your core network, and you have edge locations. So you have multiple locations, whereas you use some kind of a distributed compute node. So you have on the edge only compute nodes, nothing from the API services, etc. In some sense, what you have is applications deployed close to your end user, but you don't need to pay the price of having a full-blown control plane at the edge. Obviously, to be able to use that solution, you would need a stable connectivity, some throughput between your core and your edge. There are a lot of requirements that are required to be able to have a successful deployment with a stretched cluster. But this is a simpler solution than the last one, which is a full-blown solution. The full-blown solution is the federated cluster and federated sites, where you have a full control plane on each of the sites that you are deploying to, and on top of that, you have a federated control plane. The federated control plane makes sure you can move workloads seamlessly between your endpoints, and that each endpoint is aware of the other. So that's a more complex system to debug. You add another layer on top of what is with the other three options, but you get more flexibility. So obviously with more cost, you get more functionality. That's the way it goes. So when you go to a customer, please, first thing is understand what they're trying to do and see if you can settle for a simple solution versus going all the way down to the most complicated one. So here is an open source. What you see here is a set of tools. All of them are open source. When you combine them together, you get a stack. We'll get into the details in a second. How many people here are familiar with these technologies, or at least one of these technologies, let's say? Okay, that's a good crowd. Almost everyone actually knows at least one. Do we have somebody in the room that knows all of the technologies, all of the 5 of them? Okay, 1, 2, 3, perfect, okay. Yeah, so let's try to understand why we need, like I've mentioned earlier, we probably need a combination of multiple technologies to be able to solve all the 6 challenges that I've listed earlier. The OVS and the FR routing are 2 of the building blocks. They are very basic. I'm not going to get into too many details there because they are the basics of, I think, almost every open source solution these days. So they are given. The only question, well, I assume they are given. The only question, and what I'm going to try to explain now, is actually the upper level, which is the Ansible networking, Open Daylight, and Skydive, and the combination of the 3, and to see what they can give us. Okay, 2 words just to set context. In Open Daylight, and it's basically what gives you basic connectivity. First of all, it's the basic tunneling capabilities, security, because you can do the port groups and network policy, etc. You can set via Open Daylight the multi-cloud networking. You can do it in different ways, actually, with Open Daylight. The way I'm going to discuss a little bit further is actually based also on integration with Ansible networking, which is a pretty cool solution. So that's what you get from Open Daylight. You obviously get all the modeling and the young models, the netconf, which is standardization, the way you want to manage your infrastructure. So this is all built into this SDN controller. The next, that's kind of new. What you're going to see here is not that Ansible is new. Ansible has been around for a long time. But the Ansible networking engine is kind of a new technology. It's been around only for a few months, actually, not that long. The idea behind Ansible network engine is that it is an opinionated view on top of Ansible playbooks to manage your fabric. So, for example, if we need to set up the cloud and we need to configure our top of the rack switch, or we need to set up our router, then we have playbook written by the providers. So it's an abstraction layer on top of, for example, Cisco playbooks and Juniper playbooks and Arista playbooks. So you can just use the Ansible network engine to configure the underlay in some cases. This is integrated with Open Daylight, which is the orchestration. It's just another way, a different way of doing things. And we've seen how simple it is and how robust this solution is, because once the vendor itself provides a way to manage its own hardware, we think and we saw that it simply works, which is what we were looking for. On top of that, we have Skydive. Skydive is also an open source project. You can leverage it in very different ways. Specifically, the way we're looking to leverage it in the context of this integration is to show us the topology, like visualization tool, where you can actually see what's going on in your network, which is pretty cool. We also leverage that as a monitoring service, so you can integrate with external devices and get the alarms and that you're looking for, set up SNMP traps and whatever you need to manage your devices. The nice part is that you can see where the packet drops. Not all the times, but in the cases that we were looking at, it was very good addition for what we needed. Okay, let's see how these technologies map to the 6 challenges we've described earlier. So the first, obviously, is just the basic connectivity tool, that's Open Daylight. When you're talking about multi-cloud, multi-site, and edge, this is a combination of an orchestrator and modeling device like Open Daylight with Ansible, where we use Ansible to configure at the end the physical devices. So like, for example, configuring the tunnels. We can do that either with Open Daylight, with netconf and standardized YANG modules, or we can do it with Ansible, which is proprietary but being provided by each of the vendor. As for policy and management, it's a combination of Skydive and Open Daylight as the orchestrator and the persistent tool in this whole integration. And the last is automation. Ansible is a classic tool for automation. I guess most of you already understand that, even outside of the context of networking. So this is what we think can solve most of the networking problems in the cloud era. Next week, we have Cloud Forum, where we're actually going to demonstrate some of these things, so you will get a live demo. It's not a full-blown demo, but at least for the tunnel management of multi-site, multi-cloud, and edge, you'll be able to see some of the things being done there. And this is what we're working on. This is how we envision the future at Red Hat. So I guess that at this point, I appreciate that you've been here and didn't go to lunch. And now is the time either for Q&A or just go and eat something, because you're probably hungry. So thank you.